You have resolved this into components, right? Now, what is the next step? See, the representation of this, as I have told you, this can be represented in this manner. That is, you will have these two components, summation of forces in x direction and summation of force in y direction. This is what you will have, right? So you find out what will be summation of force in x direction.
F
What
cos
are
theta
those?
plus 240 cos 30.
Minus 500, am I right?
Yes, sir.
This will be minus 500. Then plus f cos of theta plus 240 cos of 30 degree. Please make sure about the signs. Okay, this will be negative since it is acting in the left direction. Correct? Okay. Now you can say, you can see this system, it is equivalent to this, isn't it? Because this is nothing but the representation. I mean, this resultant is nothing but the representation of all these four systems or all these forces. Correct? Now over here, if I say, if I want to resolve this, because again, the representation of this R can be in this manner. Rx and Ry. Am I right? The
Yes, sir.
representation of this is Rx and Ry. However, over here, what do you observe? Rx is, how much is the Rx value?
0.
0. Isn't it?
Yes.
Rx is 0. Whereas Ry is R. As it is very much clear from this. Now, if I want to represent this Rx, can I not say that Rx is nothing but equal to summation of force in x direction? Can I not say that? From our earlier discussion, if you have observed, अगर इसका representation ये है, okay, representation of this force system is summation of force in x direction and summation of force in y direction. But representation, this is also represented, or this is equivalent to this system, right? And what do we say? That this system can be represented in this manner, whatever I have shown over here. Again, I am repeating. This is Rx and Ry, or this force system is equal to this, and therefore from this figure, what do I observe? Rx, rather summation of force in x direction is equal to Rx, and summation of force in y direction is equal to Ry. Is this clear?
Yes, sir. Yes, sir.
Okay. So what you need to understand is this force system is represented in this manner. This force system is represented in this manner. However, this force system is equal to this force system, which is nothing but the resultant. Okay, and hence we can say that summation of force in x direction equal to Rx and summation of force in y direction equal to Ry. I hope this is understood. Okay. So let me consider okay. So let me consider, these are equivalent terms, and therefore what I can say, therefore minus 500 plus f cos theta plus 240 cos of 30 is equal to 0,
Yes, sir.
since Rx equal to summation of force in x direction. Okay, done. Then summation of force in y direction. कितने forces है y direction में? So you can see Fy and 240 sin theta. These are the only two forces. Those are associated to the force in y direction values. So I will write them. F sin 30 minus 240 sin, sin theta. My mistake. This is sin theta and this is sin 30. Okay, this is one thing, one aspect, that is the left hand side of this thing, this complete figure, right? Now I will go to the right hand side, and you know that the left hand side and right hand side, those are equal. However, the representation of the right hand side is something different. So what is the representation? Ry. क्या है Ry यहाँ पे? It is nothing but R, or in other terms, it is 200 Newton. Therefore, what I can write is F sin theta minus 240 sin of 30 equated to Ry. What it will be? 200. And see the sign. This is acting upwards. Therefore, this will be positive. This will be treated as positive 200. So what I will write? Since Ry is equal to summation of force in the y direction. Have you understood this thing?
Yes, sir.
Yes.
So this is, let's say, equation 1 and this is equation 2. From these two equations, now I am in a position to identify f and theta, both the terms. Okay? So you please evaluate. How will you evaluate? You are very good in mathematics. You can solve it. Right?
Sir, F cos theta comes out to be 292.15.
I want f separately and theta value separately.
Yes, so
Sir,
sir,
theta is 47.47 degree.
47 point
47.
47 point how much?
47.
47, or let's say 5. Rest,
And F
please.
is,
Yes.
and so force is 432.43 Newton.
Okay. Force you have got it as 4. कितना आया है?
432.43.
Okay. 432 point.
43.
How much? Can you please repeat?
So 43. 43.
ठीक है. So please verify, all of you. You have different methods to solve this. You can square the two terms and then add, and later on you can calculate the f value, and once you get f value, substitute in any of the equations and you will get the theta value. Okay. ठीक है. I hope this is understood. I will move to the next numerical. Again, this numerical is similar to this earlier numerical. So you please note down. Determine the values of capital F and theta, capital F and theta, so that the resultant of the force system so that the resultant of force system in the in figure is 300 Newton, is 300 Newton downwards along y-axis, downwards along y-axis. ठीक है, so what is the only change? In earlier numerical, the resultant was acting upward. In this numerical, it is acting downward, but there is some change in the force system, or rather the force values. Okay, so you can note down, this is 400 Newton force which is acting in the upward direction. This is another force which is of 600 Newton. Okay, there is another force which is an unknown force that you need to find out, capital F, and this is the theta value. This is 60-degree inclination. Okay, and this system is equivalent to, so over here the resultant is actually acting downward. Magnitude of this resultant is given as 300 Newton. Right? So I will give you the hint. This you can solve by your own. You resolve all this in components. Okay? This shall be F sine theta, F cos theta. This is 600 cos 60, 600 sine 60. Okay? What you do, you find out the equivalence of this. That is nothing but this thing.
सर
Yes.
सर उसमें x कंपोनेंट sin 60 होगा ना
Pardon?
सर जो फोर्स 600 न्यूटन उसमें x कंपोनेंट sin 60 होगा और y कंपोनेंट cos 60.
This one?
यस सर, क्योंकि एंगल y एक्सिस का दिया है.
What is this angle? What will be this angle?
30 डिग्री सर.
30 degree. ठीक है, so now it's okay.
यस सर.
Cos 60, rather cos 30 and sin 30. Now it's okay.
यस
Okay.
सर.
Good. Then equivalent force system will be like this for this. Then you are supposed to equate this to the equivalent force system for this. And what will be that? It is Ry and Rx. Okay. Or in other terms, summation of force in x direction will be equal to Rx. Summation of force in y direction equal to Ry. You find out these values, summation of force in x and y directions. You know what is Rx. In our case, Rx is 0. Do you agree?
Yes, sir.
Ry is R. Correct? Rather, it is minus R. Ry is minus R. So be careful about the sign convention. Okay? Substitute the values once you find out, and then find out the value for F and theta. I hope you will not find any kind of difficulty in solving this numerical. Straightforward values are there. Okay? So should I run this? We will take up next example, wherein you will find that the resultant is not vertical or horizontal. Okay, it is inclined one, right? So let us see that. So you write down the force system shown. The force system shown has a resultant of 500 Newton, 500 Newton down to the right, 500 Newton down to the right at 45 degree with x-axis, down to the right at 45 degree with the x-axis. Compute the values of capital P and theta. This is 400 Newton given. The inclination is 30 degree. This is given. Then there is one unknown force, capital P.
Sir, inclination is 45 degree.
Yes,
Inclination is 45 degrees, sir.
yes, inclination is 45 degree. Inclination is given as 45 degree. And this is one more force, which is of 300 Newton. Okay. This is equal to, since we are talking in terms of the resultant, so the resultant is nothing but effect. It is a net effect of all these forces. And how it is given? This is given like this. So do you agree? Whatever I have drawn, whether it is correct? Yes, please let
Yes,
me
sir.
know.
Yes, sir.
Yes, sir.
So the representation of resultant with whatever explanation is given in the problem statement, this is true for that. Okay. So this is the given condition. Very quickly, what you will do, you will resolve the inclined forces into their components. Okay. So what this shall be? 400 cos of 30 बराबर है, because this will be the this angle will be 30 degree, and this shall be 400 sin 30. This will be P sin theta, P cos theta, correct? And similarly, since this is again, see, this is an inclined resultant which is given. So can I say like this? This is Rx, which is R cos 45, and this is Ry, R sin 45. Do you agree? बराबर है?
Yes, sir.
ठीक है? Now what we will be finding out? We will be finding summation of force in x direction, which will be equal to Rx. Correct? So find out summation of force in x direction for left hand side part of this figure. कितने forces हैं x direction में? So I will write down, you please check. I am writing it like minus 300 Newton minus P cos theta plus 400 cos 30 equal to Rx. What is Rx over here? It is R cos 45. The R key value, it is given as 500 Newton. So directly we can substitute this R value. What it will be? 500 cos of 45. Is this equation, let's say equation 1, correct? Is this correct? Please verify.
Yes, sir.
Next, summation of force, summation of all the forces in y direction will be now equal to Ry. I will note down all the summation of forces, or rather the forces which are acting in the y direction. So let me say minus P sine theta minus 400 sine 30. Anything else? No. Equal to minus 500 sine 45. Please let me know. Correct or wrong?
So correct.
ठीक है.
Sir, correct.
If these two equations are correct, can you not solve them? You can solve them very easily. So please try to solve and please let me know what will be the values for P and theta. So how much are the values?
Sir, theta is 26.57 degree. And P is 343.56 Newton.
343 point.
56.
Okay. ठीक है. Please check this. I think these values are okay. There may be some other value after decimal point, doesn't matter. ठीक है. So I hope you have understood this thing, right? And this was related to the force systems which are coplanar and concurrent type of force systems, right? That means whatever forces are acting, those are acting at a single point. They are passing through the single point. Or a very specific term which I should repeat, that term is line of action of the force. Line of action of force. Line of action of force is passing through the single point, right? of all the forces, whatever forces are given, the line of action of all these forces, if they are passing through the single point, that is known as concurrent type of force system, right? And see, you can see if I extend this extension is nothing but the line of action of the force R. Okay. Right. So fine. Now slowly, I will just give you the introduction related to the next topic, and in that topic you will see that the line of action of the force is not passing through a same point. That is, the force system shall not be coplanar concurrent, but it will be coplanar but non-concurrent type of force system. Okay, so you can anticipate, sorry, you can anticipate that there is a rigid body like this, or let's say this is a rigid body. Okay, this is a duster, and what I am doing, I am clamping this duster at this location. That means I am holding this at this point. If I apply some force like this, what do you see? What I am doing, I am applying some kind of force like this.
The object is rotating.
So yes, what is your observation? Your observation is very correct that this object or this rigid body, if the point of application of force is like this is rotating about this point where I am holding, right? So in addition to the forces which develop, translation motion, in the sense the motion will be either this or in this direction or inclined. Okay. In addition to these types of motions, there is one more motion which is caused. As you can see, I have shown you the example. This is known as rotatory motion. Okay. So in your physics, you must have heard about the term of torque. Okay. So all these uh, torque or rotation, these are caused only because of some external forces. As you can see, I have applied some external force. Okay, and these external forces, they are not passing through single point. Okay, point of application is somewhere else, and the other forces, ये तो एक force हुआ, दूसरा कोई force यहाँ पे भी apply अगर मैं करता हूँ, even though this force is not passing through this point, same point. So like this, these are the two forces. They are acting on this rigid body and they are trying to move this rigid body. Such kind of action is known as, in engineering mechanics term, this is known as moment of force. Okay, this is termed as moment of a force. Okay, so your moment is nothing but rotation, torque. Understood? So moment is nothing but a type of force, and it is trying to rotate the rigid body about certain point. So the example, whatever I have shown you, is one such example, and there are a number of such examples which you will be observing in your higher semesters. and the application of this moment will come into picture in that case. So you will have to study the moment of a force in this semester, and the application you will find in the higher semester. So from the next class onwards, we will see what is exactly the moment of force, what are the different types of equations associated to moment, and other terminologies associated to moment. Okay? So that will be a kind of non-concurrent but coplanar force system which you will come across. So for today, I will stop over here. If there are any queries, you can ask. Otherwise, you people can leave. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Excuse me, sir.
Yes.
Sir, will you please share the recording of previous classes?
Yes, sure.
Yes, sir. Thank you, sir.
I will try to share it in the classroom itself. है ना?
Yes, sir.
Yeah.
Thank you, sir.
Thank you, sir.
Thank you.